So again, the first thing that we do in any of these questions that are rational equations, we look and see if we can factor anything. And it looks like the bottom of that first fraction can probably be factored. X squared minus 12x plus 35. Well, it would have to be x and x. I sometimes look and cheat because it's a textbook, and I look at my other fraction and I think, oh, that's probably a hint. So I'm going to go with 5 and 7, and I'm even going to go so far and guess that it's going to be minus 5. That's cheating a little bit, using the textbook to your advantage. Now, if it was minus 5 in order to get plus 35, it would have to be minus 7. I do still quickly check that. Does that work? Does that give me plus 35? Yes. Does my outside and my inside give me minus 12? Yes. So now that I've factored it, I notice the only thing missing is x minus 7. So here we're using that common denominator strategy. And once I've got a common denominator on the whole thing, I can multiply both sides by that common denominator, which would get rid of it. And you're left with negative 10. If I distribute the x, x squared minus 7x. What kind of question is this? Parabola, what do we do when we want to solve a quadratic equation? Make one side equal to 0. And then let's see if we can factor this. Have to be x and x, 5 and 2. They would both have to be negative to get the negative 7. Does that still give me positive 10? Yes, it does. And so we get two solutions. X is equal to 5 and x is equal to 2. We still have to check if any of these are extraneous, so we look at our non-permissible values. So we go back to our original equation, to wherever we are dividing. So we're dividing here and we're dividing there. What are our non-permissible values? X can't equal 5 and x can't equal 7. So this one is extraneous. But that one's fine. So there's only one solution, and that's x equals 2. Nothing to factor here. Nothing to factor here. The top here can't be factored, but the bottom can. Again, textbook's probably giving us some hints. I'm going to guess it's going to be 4 and 6. Does that make 10? Yes, it does. And so if we're getting a common denominator, this one's missing x plus 4 and x plus 4. This one's missing x plus 6 and x plus 6. And now that we have a common denominator, you can multiply everything through by that common denominator, and it would get rid of your fractions. So if you multiply that one through, you'll get x squared plus 5x plus 4, x squared plus 4x minus 12, 11x plus 32. What kind of equation is this? It's quadratic. Make one side equal to 0. Combine all your like terms. Can you see that you're going to get 2x squared? You have 5x plus 4x, but when you minus the 11x from the other side, minus 2x. 4 minus 12 will be negative 8 when you minus the 32 on the other side. Negative 40. If I'm going to factor this, I'm going to start by taking out a 2. That'll make things easier. Has to be x and x. 5 and 4. The 5 has to be negative and the 4 positive in order to get a negative 1. Quick check if everything works. Yes, when we multiply it out, it does. So our two solutions, x can equal 5, and x can equal negative 4. Go back to our original equation and look for non-permissible values. X can't equal negative 4 and negative 6. So we only have one solution again. One of them is extraneous, and the other one is fine. So unlike the radical equations, when you had to check left side and right side. These ones are easier to check because you just have to look at your non-permissible values. And as long as your answers aren't a non-permissible value, they're going to be fine. All right, so take 15, 20 minutes now to practice some of these.